This conference will now be recorded.
Yeah. Yeah. So, I mean, before discussing about this today's concepts, that is Docker, how do we install it and how do we set up that? Let me recollect it. Let's recollect it. What we had it yesterday. So we were understanding about this. The first concept that is like rolling update. So how the Ansible is helping about it to perform that the rolling updates. So that was one of the concept. But the main concepts what we are trying to understand from the rolling update is, so Ansible is having the concept of that you can manage that the group of the systems, how many systems that can be applied at the same time. That is the sequence property which is helping, and as well as before performing the actual task we can manage that the pre-task and as well as post-tasks. So like if the task which is having the dependency, so this before running over the task any predefined task, and after executing the current task, like any post task if you would like to manage it, so all those tasks that we can manage it through the pre-task module and as well as post-task module. Yeah, so that is the main three keywords we are learning from the playbook, that is sequence, pre-task, post-task. But what we were doing this for about our example, which we were having this as a demonstration point is like any updates before performing that, that is application deployments. Before that, we need to disable that's the monitoring on that service. That means an Nagios should not send us notification because there is a known activity. We need to disable that alert notification. And as well as one more activity we were trying to understand, that is load balancer has to disable it. It should not route the request to that the current system where the change is applying that. Yeah, so that's a pre-task that's we were defining that like alert to disabling this from the Nagios, and as well as the redirection disabling from the HA proxy. And then a task like update. So that is what are the role you have those are which is implemented. That's update role you can call it. And then post task again you can define it HA proxy enabling and as well as alert notification enabling. Yeah, that was the first topic we were trying to understand, and then which we were starting this understanding about Docker. Yeah, the Docker, which is helping about the platform virtualization. So for this, the virtualization concepts which are the at OS level. So if we need that, like a one bootable, one I mean application and application separate the infrastructure where we can launch into the separate virtual machine by using virtualization software. By sharing about it hardware resources from the host OS to the virtualization machine. So there is virtualization softwares which are helping. There is a hypervisors where we have the virtual, the box or VMware, or we have the Zen servers. So these, I mean, these softwares which are helping about it to manage the virtual machines on the host OS. Like there are the guest OSs which are helping to launch it, isolated application and application specific libraries and binaries. Yeah, that was the concepts we are trying to understand it as virtualization point of view. But next, the generation which are helping this is you don't need to have the separate guest OSs to manage it about your isolated application specific libraries and binaries. We can directly like launch it about this the application specific libraries and binaries on the host OS itself. That means kernel file system of the host OS. We can share it to the about our like the application specific libraries and binaries. Yeah, so that's the concept. Like it is helping to reduce that the guest OS layer from the virtualization concept. That means the platform level itself you can virtualize it directly on the host OS. Yeah, so there's a concept, the Docker, which is helping that. And the Docker, yeah, the containers. Why they have given the containers concept is, yes, like so you don't need to know about it what is the content that contains internally, and you should know just like how do I manage the container. That means container, how I can pull it, or how I can run as a container, or how I can create as an image, how I can publish my image to the repositories. These activities if you know, and whether you are supporting for the Java platforms or the .NET platforms or the PHP or the Python or the Node.js, doesn't matter of it, this all the platforms are same. So that is the main point. Like the container way they have given is, so the I mean the build it, deploy it, and the process it, the same activity which are going to do that for any type of container, but only the content within the container on the base of the application specific it is going to change it. But how these the contents you are adding this is, we have the layers concept. So that is the base image, you can take it on the base image, you can add that the multiple layers, and all these layers we can define this as in one image as a template. The template we can distribute to that wherever it is required, and you can just uh, deploy it and run it. That is where file, once that is available, how you are deploying and running that now. So you are not thinking about the where files are to launch it. So that's application related, the server related, the binaries, and the OS, everything defined as an image. That image just load it. Just that image you can download it and you can load it that. Yeah, so that's the concept we are trying to understand from the Dockers, how those are helping about it. Now let's talk about that. How do we set up this Docker containers? Yeah, so official the site, if you just browse it about that, the way that the location, where you can find it about the complete documentation of this the Docker is the docker.io is the site, the official site. You can find it all the documentations, and you can refer about it. The downloads which are required are the products. Yeah, the shape about your digital future at DockerCon. So this they conduct about it conferences, like which is for IT professionals, and you can register it. And that is in the different locations they are going to conduct it. You can definitely, and you can find it the way the Docker is required, and some resources of the Dockers, and who are all the customers who are using about this Docker, and their reviews. Yeah, so there are all the different companies so who are using about it, thus the Docker containers. Yeah, so this you can find it, the customers information and documentation information in the official site. And yes, so this how do we go for that, like setting about that or installing this Docker is, you can find it the Docker documentation. Yes, so download Docker for this Mac, or the download Docker for Windows, or the download for so there's uh, like a Linux operating system. So there's a different try a free lab. Directly you can access the lab itself. You don't need to set up this in your system. Directly you can access the cloud systems and you can work with that. Yeah, there are the different way of approaches they have given that. And and there's a developers environments and IT teams point of view. So there is like any IT operation team, if they would like to do this R&Ds, so they can browse it here and they can get it. But don't worry about it, all this documentation. But just you can simply go for that. Like in the Google also, you can find it. Suppose if you have this install in this on the Linux system, how to install Docker in Ubuntu or the CentOS or the Windows. So this approach also you can use it, which is indirectly redirecting to that Docker sites anyway. So get Docker. We have the two types of the editions: community editions and as well as enterprise editions. Enterprise edition where you can get it some support from them, and community edition where we can use it for about our training activities point of view with some features. Yeah, so get Docker, the community edition for CentOS. So here you can find it. So the complete documentation, how you can install it, what are the OS requirements, and if it is already old versions, if you have, how do we uninstall it. But I'll talk it. There is just like so where you can find it, the documentation of the Docker, if you need it, any kind of the installations or any specifications that is required. Yeah, so install Docker C, you can just browse it. You need to get the first repository, set up the repository. So install required packages, mutils and mconfig manager. So there's like persistent data, LVMs, and this is actual repository location. So there's a repository, adding that and enabling that. There's repository, and where you can find it some the GPG keys also. Yeah, so this is repository information and configuration manager, and yeah, so finally you can find it Docker, how you can install. How to install it is, once this repository is added, then you can just browse it install Docker CE, and command line interfaces if it is required, CLIs. Yeah, so these are like the package names which are helping to install the Docker. Yeah, so this is on the base of which operating system you are referring that operating system related documentation you can refer that. But let me explain this as we have this the documentation point of view as a easy way to understand it instead of worrying about the big documentation. So the simple way. So what are the prerequisites before going to install the Docker is, so whatever the, I mean, so we are going to use the CentOS or you can use the Ubuntu or whatever the system that's required, you can prefer that. And the Docker is not supported on 32-bit architectures. So we need to have the 64-bit architecture. So this is one of the important thing. So how to verify this like 32-bit architecture or 64-bit architecture of the system is uname-I. So check it with that. So the 64-bit operating system. And then what is the kernel version that is required to install the Docker? I mean, now we are saying about it, Docker has to be installed on one of the host OS. So that host OS, if you are taking about the CentOS, the CentOS prerequisites. That means, so as the diagrams yesterday, if you try to understand it, Docker engine has to be installed on one of the host OS. Now this host OS we are trying to understand as a CentOS. So now we are going to take it this the CentOS system. On this CentOS system, we are going to install the Docker engine. So to install this Docker engine, what are the prerequisites? That's we are trying to understand. That means host OS, the prerequisites. This host OS should have the 64-bit architecture and the kernel version. It should be 3 point above. I mean 3.4 or 5 something which we have. Yeah, 3.8. The Docker is supported on kernel version 3.8 and later. And some of the Red Hat Linux systems which will be having the kernel version 2.6 series. Yes, RHL which is supporting that 2.6 at least required, and Ubuntu or some other flavors if you are observing about it which are having the kernel version which is required the 3.8. Yeah, so there are the two prerequisites. So whatever the host OS you are going to take it that to install the Docker on that machine. Suppose if you like to install the Docker on Windows. So Windows also you can take this as a host OS to install the Docker engine. So on the base of the Windows 7 or the Windows 10 flavors, we have the different packages. So suppose if you just browse it, that's the Google documentation. So how do you install this the Docker on Windows? Yeah, so here we have like a option like a Docker engine is yeah, the get Docker for Windows. So there's edge channel is available. Stable edge is they are doing the some R&Ds that is not recommended. Stable one you can take it, and you can just browse it that this documentation. So this is the Windows the software installer.exe, and you can use it that to go for this install in the Docker engine. And you can refer this one we can call this as Docker engines, and you can refer about it to the Docker documentation for the Windows. So don't use the Windows, go for that one of the host OS, take it the CentOS or the Ubuntu. On the CentOS install the Docker engine and work with that. Yeah, so now what is the host we are going to take it is, so already Ansible systems we were using about it, the same Ansible system I have just started. So we are going to use it the same system. Let me log into that. Or you can take this new box, or you can work with that. That's about your choice. But take it one of the host machine as to install the Docker engine. Yeah, so uname-I, so which is helping to know about the switch, the architecture that's we have this, that is 64 is required. and uname-r, which is helping about it to know the kernel version. So what is the kernel version which I'm having is 3.10. So about this vagrant box which we have taken, that contains the 3.10. We are happy. So at least 3.8. But some RHEL based systems 2.6 or 2.7 also, which supports about it. On the basis of this distribution, you can find it the requirements. Yeah, so that is the first one thing. And as we were observing about it, the installation process point of view, first we need to install the repository. But why do we need to install the repository? Suppose if I try to install this Docker engine, suppose from the repository msearch the Docker. Now I'm just trying to find it the Docker package name. And here it is showing us a Docker package and some Python related Docker related packages and a Docker client and the common. So many it is showing about it. But what is the recommended package to install is Docker engine package. So don't try to install this only Docker, because some of that the volumes doesn't support it. Don't try to use it. This is the default Docker packages. So Docker engine is required. So that means we are going to install that that Docker. What is the package we are going to install? Is this package is recommended, Docker engine package. But the Docker engine you don't see here. So we don't see this the Docker engine over here. That means the default M repository, whatever the repository it is searching for that, in that search, so it is identify the Docker, but it is not available Docker engine. So no matches found. But I'm expecting about a Docker engine. So in which repository that is available is, so in one of the URL, so they have given this Docker engine. That repository we need to configure in our OS system. So that means to configure that, so what are the other options we are expecting is we need to configure the repository. So where the repository files by default located is etc m repositories.d. So this is the location where all the repos, suppose appel release. So that is one of the repository where it is looking about it, some of the packages from that repository. Like that in this location, so etc m repositories is the default location where all the repository files can be managed. In this location, we are going to add it one Docker related repository file. But in this file, what we are going to define is we are going to define about our Docker repository information. So that means whenever we are searching about that any the package, it is going to look at that in this repository URL also. If you just take it this URL and if you observe here, now you can find it in this location some packages. In these packages, you can see this Docker engine RPM files. They're all RPM files like the package managers. So Docker engine specific like a 17 version that which is belong to that the community edition related files. RPM files are located here. You can download this RPM file and you can install that using RPM-IUH also. We can go for that. But instead of using that RPM file, we would like to install this using M approach. So, but whenever whenever you are running about it, M is looking about it, this particular package in that base URLs. So that base URL is not available by default. That base URL and that base URL is required related to some keys we are going to define in this repository file. Yeah, so in this repository file, so m repositories.d in this location, so we are going to add this content. But this content, what does it contain is about our where exactly the Docker related RPM files are located, that RPM files related URL, and which is required enabling, yes, and keys checking required or not, yes, and which key. So this is the key location. Yes, this entry is required to add to this the file which is having this the extension dot repo, and this file where do we need to manage it is that is in etc m repository string. Yeah, so this is the content. Let me take it this content, and if you go to that etc m repository starting. So here if you observe that some repo files are available, some device related base packages information, apple related the base packages. So all this the urls that is defined here. So like that, now we are going to add it about our docker related repository file, docker.repo. And what the content is, this content is required to add it there. Yes, we are giving as a docker repo name, and this is docker repository, the base URL where that the complete. If the CentOS the 6th version, then the 6th version related the repository URL we need to define. On the base of this, the which version we are using, that version related the URL you can find it here. Suppose if you go back, sorry. Now we have the 6th version, 7 version. If it is the CentOS 7 version, you can find this URL. If it is the 6th version, you can find it this 6, and this 6 URL you need to define in your repository file. Yeah, so that is adding the repository base URL on GPG key. Now let's save this file. Now after saving, if I go back and if I run my command, that is m search with the Docker engine. Now it is going to refer to the Docker repo file also. So now it is going to use it that the repository name which is having as Docker repo. Docker repo, that base URL it is taking that in that URL. So we have the Docker engine. Yeah, so if you just observe this in the search, it is find it now that Docker engine is the package which is available, which is specific to that 64-bit architecture. Now this one we can install it. Now let's go for installing this one. Yeah, so that's about how do we add the repository, and after adding the repository to the repo file, and how do we install the package. And before that, make sure about it what are the system you are taking, that the system which is supporting the 64-bit architecture with the kernel version at least 3.8. Yeah, so that's about installing the package. And once the package has been installed, the next we need to, always Docker engine is the process which is running on the host. But what is the process and which service we need to start it? Yes, once the package has been installed, yes, so M update. Anyway, I hope so we have done already M update for Ansible requirement point of view. If it is not done, so at least one time so you need to do M update. And we need to start the service. What is the service name we have is Docker. So start the service and enable the service. We know these are all service level commands. And if you like to stop it, you can stop the Docker, and you can check this Docker is running or not by using Docker info command. We'll come back to use it, and then you can check it that's which version you have installed this Docker version. Yeah, so let me do all those activities. Yeah, the Docker is installed but it is not active. Let me start it. Yeah, so that has been started. Yeah, the Docker is active now, and let me enable that also as a boot up point of view. Yes, it has been created, the boot up process. And yeah, so now let's verify the Docker info. Yeah, so we got this message, nothing but the Docker service is up and running. The Docker daemon process is not running, then we cannot to see this the Docker information. But what are the information that is showing? We just observe that. Yes, how many containers currently are having this on this system, but we don't have any containers so far. But if the containers are up and running, how many containers are running statuses, or how many containers are in positive statuses, how many containers are in stopped statuses, and how many Docker images that we have in our system, and what is the Docker server version information. So there's the same information you can get it Docker version command also, that is 17.0. This is a community edition, and a driver which is using as an overlay. I'll come back all these points the later about it. And yes, the plugins, the spam we are not using, we'll come back to that, like the Kubernetes activities. And you can find it, the container versions and init version, the kernel version of the system 3.10, which OS it is using, CentOS, Linux, OS type, OS architecture, how many core process units that have been defined, what is the total memory, and what is the host name of this, and complete Docker. That means whatever the images which we are going to create it or use it, or what are the containers we are running. So all this the containers related, the complete location where it is managing is, this is the default location. So this is important directory. So where lib docker, this is like the Docker home directory. So Docker root to directory. So this like where it is managing all the images and containers information and the volumes if you're creating that. So all the complete information that stores here. And a debug mode, so they're not enabled. Yeah, so that's about some information which you can find it here, and you can check it as the Docker version also. And whenever we are verifying the Docker version, it is having the two options, like one is a client version and server version. But what is this? Why it is having the client and the server as a two different options? I'll come back later. But client-wise version, which is having the 17.0, and the server is also same. But when do we say that the client? When do we say that the server will come back? Now the daemon process is running. Now the Docker background is running. That is the server. Now suppose if you are running the Docker info command, that means you are the client. You are submitting some request to this Docker daemon process. And so this from the command, or what all the commands you are executing this which belong to the Docker related, so which we can call this as client specification. And once if you submit this request, the Docker server is receiving this request, and the Docker server is processing this request, and the Docker server is going to return back that output to the client. That means Docker info, if I run it, we got this message, or this information is nothing but this complete information is forwarded by server internally. That means daemon process. Yes, so that is like a client and server architecture we have. That means any Docker command you are running is nothing but that is a client, and to which server you are connecting that server, like which we can say this the daemon process is the server. But that server we can use it on the same host, or we can use it about the remote host also. Suppose on the remote host already Docker is installed. Now this system I can use it as a client to connect it to the Docker server. So we can set up the some export environment variables, like where the Docker host is located, that URL, that means IP address and port number of this Docker, and we can run this the commands from here to this that's remote system also. But what is the file, that is I'll explain this later. Yeah, so this is the client and server architecture which is supporting that. And yeah, the sometimes what is the problem this way how this is. So whenever you are trying to start this the Docker process or the Docker info, we will be receiving about it the Docker daemon process running on this host or not. Yeah, so if you, I mean, if you get this kind of the exception, then make sure about it the var run docker.sock. So this is the main file, Docker socket file. So this socket file, the current user who is using this as a client should have the permissions. So whatever the current user you are using about it, that user account you need to add to the Docker group. Yeah, so that is sudo the user modification. So what are the user account you would like to use it to run this all the Docker commands, that user account add to that Docker group. So this is recommended. Otherwise, you cannot run this Docker process. Suppose if you just verify that file, yeah, so this is the file and current user we are using about root user account, and this root user account already added to the Docker group. That's why we are able to run it all these process. That means Docker start commands, Docker info commands are systemctl start Docker is successfully started. But if you are using some XYZ user, and that XYZ user also should belong to that Docker group, then he can ask about this daemon process. This is the main Docker socket file. So which is this is taking this all the request from the clients as a server process. Yeah, so there's make sure about it. So on this file, the current user, whatever the user you are using, should have the proper permissions. Yeah, so that's the concept. So which we have this on this Docker, like installation setup. Now we are good with this the Docker. We are able to run this Docker commands, Docker info, Docker versions. So this points is what we have done. If you just observe that repository we have added to the Docker repo file with that base URL and GPG key check. And after that Docker engine we have installed, and we have just started the process, and we have verified that the process up and running or not. Now the Docker engine is ready in our CentOS system. But what is the next activity? Why we have set up this Docker engine is to run about our applications. Applications like that is Tomcat or the Jenkins or any kind, or you can launch about your OSs also, like Ubuntu system or CentOS system if it is required. Then you can launch it with the Docker also. But before launching about it or before working with that all those concepts, let's try to understand these two important keywords, that is image and container. So we can take it as the base images, or we can find it the base image, like whenever we are working with the virtual machines. If you need that any virtual machine that is sent to us or the Ubuntu, you can go to the Vagrant upsite, and you can search the particular Ubuntu or the CentOS, or which image is required, that which OS related image is required, that image name, get it, and use that the Vagrant init command or Vagrant up command to launch it. Like that, here also on the basis of about our requirement, we can find it the base images from the Docker hub repository. The Docker is providing ready-made images. If you need the OS images are available. If you need the platform images are available. But in our Vagrant, only the OS related images are available, not the platform level. But here you can find it the OS. If you needed the OS image, you can download it, you can run it. And if you need it the platform, that is the Jenkins or the Tomcat or Apache or Nginx, yes, so find it and download it. Yeah, the base image we can find it, but the base image, once that is available in our local the system, that means the local repository, but we need to run as a container. Suppose once Vagrant box is downloaded, we are using Vagrant up to launch the virtual machine on the virtual box. That we are running as a virtual machine. Vagrant box we have taken, that is image we have downloaded, and that image we are running as a virtual machine by using Vagrant up command. Like that, the images you can find it and you can get it, and we can use it run command, Docker run command, which is helping to convert that image or to run that image as a container. Container is like a virtual machine. Suppose if you have downloaded the Ubuntu image, and Ubuntu image, after once that is available in our system, then you can use it a Docker run command, and if you run this Docker run, that image is going to run as a container. That means virtual machine, Ubuntu virtual machine is available. But how to get it these images and where these images are available, we'll come back. Yeah, so once the container is available, you can log into the container. That's you can connect it to the Ubuntu system, and you can use it as a normal system, and you can create about your own commands, and you can install about your own packages. And once packages and everything is done, this is about your custom container. Now this custom container you can create about your own image. Like I have taken the base image, I have run as my container. That container I have modified internal some packages, and once the packages as per my requirement, once that is configured my container I can create as my image, my custom image, that is about our image. And this image you can take it and you can upload to the repositories, and you can take it, this image you can run as about your containers, like multiple containers you can run it. But how do you run that image as a container is Docker run. How do we convert the container as an image is commit, Docker commit. Suppose if you just remember about it, about our git commands, git commit, git push, git pull. Git push, which is helping about it from about local files, local repository files, you can push it to the remote repository. And if I'm having some update in the remote repository, how I can get to this local repository? Git pull, git push, local to remote, git pull, remote to local. Then first of all, I need to commit it, the files to the local repository. How I can commit it? Git commit. Like that, Docker commit, Docker push, that is local image files, you can push it to this Docker hub repository. Like there we are seeing the GitHub. Here we say that Docker hub. Where that all the images are available is Docker hub. And if you need that any image, Docker pull it. And if you have this any image in your local system, yes, Docker push it. And if you like to create about your image, yes, Docker commit it. Yes, these are all some commands like a Docker commit, Docker push, Docker pull, and how you can convert that image as a container is Docker run. Yeah, the two main keywords: image to container, that is Docker run. Container also can create as an image, that is Docker commit. And container, once the image is available, image you can push it, that is Docker push to the remote repositories, or if you need it any other images you can pull it that. Yeah, so there are some terminologies which are helping about it, but anyway we'll come back one by one understand. But where all these images are available, that means we'll try to understand that Docker hub repository. So if you just browse it, that's dockerhub.com. This is like a GitHub, how we have created about our own repositories to upload the files or to download the files. Here also, I mean, in this Docker Hub also you can create about your own account, that is sign up. You can sign up that as a open account and the free account. And if you need that any kind of the images, you can find it here. Like in the vagrantup.com, how we are searching for that Vagrant boxes. Here you can find it. Suppose if you needed the Jenkins container, you can just find it the Jenkins. And this is the Jenkins, the ready-made image available. That means if if you have any system which is having that the Docker is installed, just you can browse it about this directory, I mean this Docker hub, and you can find it which image is required, and you can search it about this the image which is required. And if we don't, I mean, as we are trying to understand in GitHub, like the same thing, if you don't see this any user account before this, then this is the official one. That means official, the Docker hub is published about the Jenkins. Yeah, this is official Jenkins Docker image. And somewhere if you observe that, so here it is Jenkins CI/Jenkins. That means he's the user. This user is published about the Jenkins image. Like that in the background also we have that, the same concepts. Yeah, so you can find it, the image which is required. And once, if how you can download it, if you just once the image is identified, if you click on that the image, now you can see this the copy and paste to pull this image, and go to this where the Docker is installed, and take it this command Docker pull Jenkins. So by default it is going to try to communicate with this dockerhub.com and tries to push to this about your local repository, like how we have the Vagrant up and then the box name. Yeah, so here you can see the different versions also, Docker pull Jenkins. And what are the different versions, and which versions that is supporting is here. You can see that So here in our Docker, the images point of view, the versions, we don't call the version keyword, we use that tag. Like in our GitHub also, we can tag that about our code, labeling, like that. Here, so there's, I mean, if you don't see that any version here is nothing but that is the latest version. But if you'd like to download the Jenkins specific version, how I can find it, the Jenkins specific version? In our Docker terminology, instead of saying that the version, we call this as tags. You can go to the tag section, and in the tags you can find it list of all the tags which are available. Yeah, this is the Jenkins 2.60, and this is the latest one. If you don't specify that the any tag here, the latest which will be downloaded. And this is the 2.60 Alpine. So there's a different versions are available. But how do we use the version is, suppose if you would like to download the Jenkins this version 2.32.2, then you can take this version, and what is the command you can use it is, so simple, the colon and the version 2 point something, whatever that I forgot it. So 32.2, the version number. If you don't specify this any the version here like this is nothing but latest version. Yeah, so you can find it. Suppose if you need that Ubuntu system, you don't need to now look it about that the Vagrant boxes. Now you can just, if the Docker is installed in your system, look at about that Ubuntu system from the Docker images itself. So you can go to here and you can identify that official one, or the custom one which you prefer it. Then the Docker pull Ubuntu. And the Ubuntu we have this like the 16 version, the 14 version, or the 18 versions. So if you need that those version specifications, then you can find it 18.04 or 18, the 19, 14, 14 which you call this as a trusty also, the 16 which we'll call this as Xenial, the 19.04 Disco, Cosmic, Bionic. These are all the names which we have this. Or you can refer to the tag section here. If you go to the tag section, so here you can find it Xenial. Xenial is nothing but that is a 16 version, and Xenial with the specific data distribution. So the 16.04 or the trusty, or the trusty one 14.04 developer disco. So they're all like the different the versions are available. Which version of the Ubuntu that is required? So just to take the Docker pull Ubuntu and version you can specify here. Like the CentOS or the CentOS you can find it, or the Tomcat if it is required. That means you are getting about your OS distributions and as well as Tomcat. So if I go for the Tomcat, so just take this Docker pull Tomcat and a Docker run Tomcat. That's all. My Tomcat server is up and running. You don't need to worry about it. Java installation, you don't need to worry about it like a path environment variable setting, and you don't need to worry about it like a I mean the Tomcat server, how I can start it. So that's the beauty of these containers. I mean that is everything is bundled in this image. So whatever you are expecting, the base image of the OS file system, and then like the Java file system, and then the Tomcat file system, and the Tomcat starting stopping, and everything that is defined in this. Now you can find it in the different version. Tomcat, which version that is required, that version related. The Tomcat you can find it and you can download it, and you can see the some documentation. So what is the Tomcat, and how to use this image. How to use this image is docker run -it. What is these arguments, I will explain this later, and a Tomcat 8.0. That's all. So it's going to take care about it. I mean, so you don't need to pull it separately. Suppose what is the feature which you have is like whenever we run it about a Vagrant app, that box which was specified in the Vagrant file that is available in the local the system or not, it is going to check it. If it is not available, it tries to download it from the vagranthub.com, that is from the cloud. It tries to download it like that. So whenever you run the Docker run with that the image name, this image, and with the tag, that image with the tag, is it available in the local repository or not, it is going to verify it. That is a var lib docker in the docker home directory. I will show this later. So that is available in that directory or not, it is going to check it, that image. If that image is not available, automatically it connects to that the Docker hub site and it tries to pulling, and it is going to run it. But pull is going to do that only one time, the first time. If it is already pulled it, then it tries to run it. If it is not available in the local, then it tries to pull it and it tries to run it. Yeah, so so Docker run with -it, and we have the port publishing. I mean, in the Vagrant, we discussed the three concepts: synchronized folders, the network configurations, that is IP addresses, public or the private IP address, static IP address, how to configure it, and the synchronized folders, port forwarding. The same concept, that is virtualization concepts. Whatever we discuss, the same concepts we are going to talk it in the Docker also. I'm having this like a Tomcat 160 started with the 8080. How I would like to access about it. So that the port forwarding options which we have, I'll come back later. So we have so many arguments for this Docker run command, but just try to understand it. So how the beauty has come up with that as a platform level virtualization. Yeah, so that's understanding where you can find the images of this Docker, and how you can find the documentation of it. And so like you here also you can create that account, and you can log in with that about so it is just asking us the 3 or 4 properties only. So just sign up that and log in here, and you can create about your own repositories, and you can upload about your own containers as well as. But I will come back how do we upload about our containers, which we'll see. And you can create about your own repositories to upload about your images. That's how to create that repositories, and how do you work with that repositories, will come back later. But that is the concept, like images are available in the Docker Hub. You can pull it and you can run it. Run is nothing but you are creating runtime behavior of that image. One image you can create multiple containers. Suppose once my Tomcat image is downloaded to my local system, I can run multiple Tomcat containers with one image. Yeah, so there is a concept like understanding before talking about it, how to launch it and how do you work with that. Yeah, the Docker has a number of base images on the Docker Hub. Yes, you can find it, including many versions of the Linux distributions. And the base image, what the base image it is taking, this is CentOS. So all these images which are used or which are defined with the CentOS as a base Linux distributions. And the Docker search facility, that means using Docker search command, you can search about your the images using Docker command also. Now just whatever we have seen in Docker Hub search options. So in the Docker Hub search options, the same thing in the command line also you can do that. But this is instead of that you can refer about it as GUI based. Suppose if I just give the CentOS, now it is going to list that all the images which are available in the repository. But you need to find it. So this is a difficult, somewhat difficult to identify here. So refer about it, the GUI based, and identify that image name and use it that Docker pull image. Yeah, so how to pull it and how to run it. The pull and run commands already we had about it. But the point what we have is a Docker image must be located on the local computer. So it may have been created locally or it may have been pulled from a repository. But the image should be or must be available if you would like to run it. If it is not available, it is going to try to pull it from the repository. That is auto behavior of the Docker. Now let's look at about it, how to pull it and how to run the containers. Okay, now so the before talking about it, all this Ubuntu and about our custom the images and all the points. First, let me take it this one hello world image, which is available in our Docker Hub repository, and we'll work with the hello world. So you can find it hello world some image here. Yeah, this is the hello world updated an hour ago itself. Yeah, so now we try to pull it this image and we'll try to run this and whether we are able to successfully run that image as a container or not. Now first let's pull it this image. So how to pull it the images? Docker pull and image name hello world. And what is the default tag it is using is we didn't specify this any tag, so it is using latest. And it is pulling from the which repository, that is a library, that is a Docker Hub repository, and with the image name which contains hello world. and this is one image. As we are trying to understand that the image is that multiple layers, like the base image, on the top of that another image, and finally container. Yeah, so this is one layer which is defined. So for this hello world, so they have created only one layer for that. So don't worry about it, all these layers. I will show this about our custom layers when we are discussing about it. And status what is showing downloaded newer image for hello world latest. Yes, now in our local repository, this hello world image is downloaded, available in our local system. That means, like in the vagrant point of view, the vagrant the init command which is helping vagrant file, and you can box add it. Box add is the command which is helping to add the vagrant box to the docker repository. So same thing here, it is the docker pull command. But where this image is located, for the timing not required to know about it, but if you'd like to know about it where this is located is, wait that the main directory we are saying about it, but the docker home directory is varlib docker. So this is the directory. In this directory you can see this. So any containers you are running is nothing but all the containers will be stored here, and any images you are pulling or you are creating locally is nothing but all the images that will be stored here. The networks or the overlays or any plugins you are installing or any volumes you are creating, we'll come back to that. So volumes point of view, the networks point of view, we'll see this one by one. So on the base of the which type of the resource you are doing that from the docker containers or the image or the networks or the volumes, so that's it is managing as the directories point of view. Now image we have downloaded, where that image is located is in the image folder, and here you can see there's the overlay. Yes, it is using the overlay concepts, but what is the overlay, I'll come back. We have this one kind of the network driver, and yes, here you can see this image db is the directory. In this image db, and we have the content. So this is a hand SHA model 256, and this is the image ID. Now if we just observe this, whenever it is downloading, so what it is having SHA 256 here, and this is having that some ID over here, and status which is showing the downloaded. And now this is the image ID it is creating. But what are these IDs? Suppose if you just observe this or remember that in our git, whenever we do the git commit is going to create one hash code, right? That is unique version of that commit. Like that, any images you are using or any kind of the containers you are creating, all these images or the containers are going to have one unique ID. With that unique ID, it is stored in this location about this image. Yeah, so now so this is the image ID so which is available. Yeah, so and here you can see this, like that image related all this sorry, yeah, so all that image related all that options you can find it here. Now this is the image ID which is available, but how do we find it, or how do we look at about it? This image is what is the one more command which is supporting is to identify list of all the images. Suppose if I just give that docker images, now what we are doing, that physical location we are verifying here. But instead of using the physical location, you can use it a docker command, docker images. You can find it list of all the images which are available in our local repository, the docker images. So what is this, the image name which you have is the hello world, and what is the tag, that means version latest, and what is the image ID that we have is FCE. If you just observe this in this location, so like image overlay, image db, content SHA 256, what is the image ID it is having? First 7 characters or 8 characters you can find it here, FCE 289, FCE 289, E99 EDB something which we have. So that means in our git logs also, if you just remember that, so we have the 7 or 8 characters of that the commit information, like that. So any images you are working or any containers you are working, all these images or the containers are managing in our local repository with the unique IDs. Yeah, so this is a unique ID which you have for this image. So image ID, and created, yes, 2 months ago it was created, so we didn't create it. And what is the size of this image? If you just observe that, only 1.84 kilobytes of that image. So Vagrant boxes are, if any of the CentOS or any systems you are trying to download it, like which have those like 1 GB or the 2 GB or the 3 GB of the size of the files. But here, simple, which is having this, even that 2 KB also it is not there. So that's file where you got it from the image. Yeah, so there's the two options we are trying to understand. How do you pull it? The image, Docker pull and image name, and with a specific tag we can define. And once the image is pulled, all these images where it is storing is, so that is in our Docker, where lib Docker, in that location, image database it is managing separately with its specific unique IDs. But how I can see this, like all the images which are available in my local repository is Docker images command. Okay, so that's about image point of view. How to pull it and where it is storing and how you can find it with the Docker images command. Yeah, now this hello world I need to run as a container. But how do you run as a container? So what is the command which you have is Docker run, and what is the input for this Docker run command is which image that do you want to run as a container. So that is hello world. And if you have this any specific tag name, if you don't give the latest, if you have this any specific version number. Now if you just observe this Docker run hello world, this container what it is printing is hello from Docker. Yes, this is just saying the some hello. This message shows that about your installation appears to be working correctly. Yes, it is working successfully. To generate this message, Docker took the following steps. Yes, this is understanding about client and server architecture. Yes, whenever we run the Docker run hello world command, what exactly is happened the backend? What exactly is happened is Docker client. That means about our Docker run command. Client contacted the Docker daemon process, that is var run docker.sock, that is the process. To that process the request is forwarded. The daemon pulled the hello world image from the Docker hub. The Docker daemon created a new container. Yes, it is created a new container from that image which runs executable that produces the output you are currently reading. Yes, the backend the Docker daemon is executed this hello world image, and it is whatever the output which is generated. So that output, the Docker daemon streamed that output to the Docker client. Client is nothing but here about our terminal. So this Docker daemon streamed that output to the Docker client, which is sent it to the about our current terminal. Yeah, so this is the client and server architecture. That means you are running Docker images command. Docker images, who has listed all these Docker images is Docker daemon process running that. Yeah, there's a client and server architecture. Yeah, so there is a to try something more, like you can work with that the Ubuntu, so which will come back to this. Now we are going to do all these things. Yes, that is like image as run as a container, and container that is just printing that output. That means in that container, in that image, who has implemented that image, they have done like printing some this output. So we have this, I mean, to list it all these Docker images, we have the Docker images command. Like that, do we have any command to list it all my containers which are running or which are stopped in my system? Yes, we have this one more command to view that list of all the containers. So how do we see this list of all the containers is Docker ps command. The Docker ps, which is helping to list it all the containers, but no container is up and running. So that means Docker run hello world, this image is run as a container and it is streamed this output and it is exited. That container is stopped. If the container is up and running, all the containers which are up and running will be listed in the Docker ps command. But how I can see this list of all my containers which are up and running and stopped is, so we can give that the ps-a for all that is stopped and running, all the status of the containers you can see here. Now we see here one container which is available. But what is the information of this container if you observe that? So what is the container ID? Yeah, this is the ID which is generated for this container. That means as we are trying to understand, each container or each image is going to have this its specific unique ID. That unique ID, which is like as a Git format, hash code representations, how we have this in our Git commit. Like here also it is going to assign this one unique ID for that image or the containers. Yes, this is the unique ID. And what is the image it is used? Hello world. And what is the command which is executed in this container is hello. That means this is the file which is executed. That means in this image they have created this file, and whenever we are running as a container, this file is executing and which is having this content. Yeah, so hello is the print command is executed, and when it was created, 3 minutes ago it was created. And what is the current status is exited. So there was run it and exited, and yes, exited with the 0 status code and 3 minutes ago. So it was 3 minutes ago it was stopped, and no ports are defined here, but we'll come back. So if you're using Tomcat or Apache server, the ports are also available. MySQL, all these things like the ports are available. So any ports you can find it here of that container, but no ports for this. And what is the name? That means each container, whenever it is running, it is going to have unique ID, and as well as it is going to have unique name as well as. So it is generated some random name. So Gerland underscore Herman, some names which are generated, but we can assign the specific names. We'll come back to that. Yeah. So this is a complete container information. So now the Docker PS, which is listing the containers which are up and running. Docker PS-A, so which lists that the containers which are stopped are running all together. Yeah, so that's about how you can pull the image and where the images are storing, and how you can see the list of all the images which are available in the current repository, and then how we can see this list of yeah, how we can run as a container, that is Docker run command. And once container is executed, whether that is up and running or not, how to check it? Docker ps, and all the containers which are up and running or stopped, that is Docker ps hyphen yeah. So this is about the basic condition in this. There's a Docker image to this the I mean pulling that image or running this the containers. And the storage location, this is important location. So now we have created container. That means in the containers folder, if you observe, if you just browse it, you will be having this one more container related file. Yes, so how the Docker works. These are we are trying to understand. These are having the client and server architecture. What is client and server architecture is? Yeah, so any commands you are running is nothing but that's Docker pull or Docker run or any commands. So it is going to try to communicate with the Docker daemon process. Docker daemon, and the Docker daemon is managing all these containers and all the images, which is going to have its specific indexes. And on the base of the request which was submitted, the daemon process which receives it and which returns the output to the Docker clients. Yeah, so this is a the client and server architecture. It's yeah, so this, I mean, this same story which is defined here. You can just browse. And now how to pull it and how to run the content. Now we take it about the Ubuntu one system, and how do we launch the Ubuntu system, and how do we connect it to the system, and how do we execute the commands. So how do we manage that? That's Ubuntu. So we go for that working with the Ubuntu. Hello world is simple, like it just prints that message, but we don't have this option to log in and to manage this like as a virtual machine. Now we go for that Ubuntu image, which is having the tag as Xenial. That means the 16 point version will take it off it, and then run as a image as a container. So Docker run with interactively. Yes. So the first hello world which you are observing the Docker run command and with image name. But now here we need to we need to log into this the Ubuntu system. But how do log in? Login you are expecting is nothing but interaction required. But any container you are launching is nothing but the container. If you are expecting this any interactions, then you need to start that container with interactive mode. But how I can use it interactively to launch my image as a container? So Docker run. So what are the other arguments which you can pass it to this Docker run command is -i t, interactively with time to live. So with -it, and then so you I mean that is image name, whatever the image which we have, And finally, which, I mean, you are saying that the interactively. Interactively is nothing but you need to run the commands. Commands you are trying to export is nothing but shell is required. Which shell that you are expecting to interact with this container? So do you want to use it the normal shell or the bash shell or K shell, C shell? So the particular shell you can pass it here. So this is a command which is going to helpful. Now let me go for running about this command. Suppose if I run directly, I'm not going to use the full command separately. So I'm trying to run it about directly docker run and -it ubuntu, and which is having the tag as xenial and with bin bash. That means I would like to use the bash shell. But pull is not run separately. As we are saying about it, we need to pull it and we need to run it. But run is going to check it, unable to find the ubuntu xenial locally. First it is referring to the locally. In the locally, if it is not available, then it is trying to pulling from library, that is docker hub repository, and with this ubuntu which is under xenial. Now these are all the layers which we have for this ubuntu image. The 4 layers it is having, all these layers it is pulled it, and it is downloaded a newer image for this ubuntu xenial. And now if you observe that here, which is on the root account, and with this some host name which is defined dynamically. Now we are in about our CentOS system, or now we are in about our ubuntu system. So now we are in ubuntu system, not in our the CentOS system. Suppose if you just observe the cat, or okay, let me go for that again. Yeah, so it is showing about it. This is also Linux GNU. TC. So it's showing network manager. Yes, you can find it. Okay, let me get it about this ubuntu flavor on command. Let's be release happen here. Maybe some packages are not available in this image which are taken. Okay, let me verify this any other comments. Well, sometimes these images are not having there's all the packages which are installed, so we don't get it the complete information. So I'll show this one option. Yeah, the issue. Yeah, so now if you just observe this is the ubuntu version which is showing about it. Yeah, so now I mean whenever we are running about the container, if we just observe that with the bin bash, so what it is doing is it is trying to pull it if that image is not available, and automatically it is connected to this about our Ubuntu system, and where we are now all these commands we are running is nothing but there's an Ubuntu system. Yeah, so there's helping about it how you can interact with that about our container whenever you are launching. So that is -it. So with that run command, which is helping to log into this about our the container as well as. Suppose now, so if I exit this, now my container is up and running or is it stopped? So if you just verify that, so whatever the interactive mode which we have used and which we have logged into the system, and I mean remaining commands you can run it as that. So, but we have the limited packages one, which is I have the lightweighted about this the Ubuntu image. And if you just verify that the Docker image is one more command. Okay, let me show this here. And this is the Ubuntu image, which is I have the size only 118 MB of this Ubuntu system which are downloaded now. That means this virtual machine, normally if you just observe that about our Ubuntu boxes or the CentOS boxes you are trying to download, approximately 1 GB of the sizes we'll be having. But this Docker image which you are downloaded for that Ubuntu system, now we are able to run that Ubuntu, all those the Ubuntu related the activities you can perform here. So Ubuntu, if you just browse it here, which is having the only 118 MB, that means only the less packages which they have given that. That means even if you try to run it, if config and all those commands are also not working. Net tools are not available. Some packages are not available. You need to go for adding about your custom packages which are required. This is the base image they have given. On this base image, you can add it about your packages and you can set up this about your own containers. Then once about your product based container is ready, then you can create as an image. That image you can use it in your infrastructure. So that is the like the flexibility which they have given. Yeah, so there is a 118 MB, and now if you verify that the Docker process, now my Ubuntu system which I have connected, and whenever it is connected, I'm able to run as a virtual machine. And simply if I do the exit of this container, my system is also stopped. That means my virtual machine also is stopped. Container is not running is nothing but about your system is stopped. But can I run this one as a background process? Now what we have done here it is, so docker run -it, if we use it, it is just interactive-wise it is helped, and what are the commands you would like to run it, and then exit is nothing but our virtual machine is also stopped. But if you're expecting that the 24/7 to run it about that, we have this the approach daemon process. That means you can run the container as a background process by using -d is one more argument which we can pass it for the docker run command. I'll come back this later. But before this, if we just verify that the docker ps-a, that means first we are running about it as a foreground approach. The background, I'll come back. The docker run -it is foreground approach. Once if you exit it, container is also stopped. Now if you observe there's the stopped containers, yes, this is my Ubuntu container, and which is what was the command we are running about it is bin bash command, and which was interactive, and 6 minutes back it was stopped. Yeah, 6 minutes ago it was created and 2 minutes back it was stopped. And what is the name? It is created dynamically, is Gen Baba, something which has been created. Yeah, so this is about my Ubuntu container, and now my container is stopped. Can I run stopped container as can I bring this back? Yes, we can start the stopped container. But how you can start the stopped container is, so we have the docker start. I mean, these are all the life cycle operation. You can start it the container, you can stop the container, you can pass the container, or you can remove the container. So we have some operations to perform it. But the point what we are trying to understand is whenever I started about it, the foreground approach, which is interactive, which is accepting it, and once it is exited, the container is also stopped. But the stopped containers, once again, we can start it or restart it. But if I start it, okay, let me, but how I can start in this container? So docker start command. But what is the input is? You need to pass the either name of the container or we need to use it container IDs. Either ID we can use it or the name we can use it. So let me give the ID. Yeah, so now this container has been started, but how do I know this it is started or not is Docker PS. If you just observe that, yes, now we have the Ubuntu which is up and running. Now it has been started as a background. So, but a Docker run command, or I mean, which is helping. What is the difference between the Docker? Can I use it to directly that Docker start on the image? No, we cannot use it. Docker start on the image. Docker start, which is helping on the container, which is stopped. You can start it. But image, how I can create as a container is Docker run. If you use the Docker run with -it, which starts as the foreground, and you exit, yes, it is stopped. But stopped one, if you like to start this the container, Docker start command. The Docker start, and yeah, so now it is started. Now the point is, okay, my Ubuntu system is up and running. My one virtual machine is up and running, Ubuntu system. But how I can connect it to that? And now before the Docker run with -it, whenever we run it, it was started, and it was where it is connected also. That is, we have logged in also automatically. But now my container Ubuntu container is up and running. But how I can connect it that? So what is the one more command which is available is Docker exec. So Docker exec, which is helping about it. Like any containers which are up and running, those containers you can log in it. That is like as SH, how we are using about it, SH like to connect to the system. So Docker containers, how do we log in it is Docker exec and with interactive -it, and we need to pass it about this the container ID here. Yes, which container this we want to connect it, the container ID. There are arguments to this exec, and which shell. Yes, you are connecting with interact, but which shell? So the shell name here. So this is the command which is helping, like you can connect or you can log into this existing container, which is up and running. That means we run, I mean, we don't use a Docker run always. Docker run is only initializing the container. But once container is available, we'll start it or stop it. How we can start it, stop it is Docker start command or Docker stop command or Docker restart command. But once that my container is up and running, how I can connect it? How do we connect it to this the container? So that is Docker exec. So if you just verify this now, now we are in that Ubuntu systems, which is having the 16.04. So on the basis of type of distribution, so these files are going to change. Yes, you can. So these are now we are in that Ubuntu. You can perform that like the PS. If you just verify that PS-ef command, so we have the only the only one process which is running. And what is that process also? If you just observe that bin bash, no other processes are up and running. So only this about our bin bash, and why it is a bin bash is also started is nothing but we are asking about this terminal. This terminal is until the live, this bin bash is up and running, and once if you exit this, then the bin bash also will be stopped. That means no other processes are running on the system. So that is the beauty of that. That means you are optimizing about your resources. Now, if you need that the only Tomcat on the system, so the Tomcat add it and use it that. That means mostly the one container, one process representation. Like suppose normally we can take it the Ubuntu, we can launch the Apache, we can launch the Tomcat, multiple process on the same system. But in the containers point of view, that is not at all recommended. So one container, one process. That means if you're going to take it the Apache, only use it about the Apache purpose that container. So that is a single process is recommended. Multiple process, if you're talking is another, that is normal virtual machine again. I mean, the multiple applications in the single host you are launching that. Yeah. So mostly, I mean, so no process are running, and if you need that any process, you can launch it that. But the recommended option is single container, single process. But one container to launch it, that Apache and a Tomcat, no, that is not at all recommended. You can launch it. So you can launch it as a normal Ubuntu, you can take it and container, you can install it, Apache, and you can install the Tomcat, and you can launch the two process. But management activities like a Docker features point of view, that is not at all recommended. One container, one process. That means container you are stopping is nothing but even suppose Apache is required in that process. You are stopping that Ubuntu is nothing but you are stopping that Apache process. And you are starting the, sorry, you are launching the Ubuntu is nothing but you are launching that Apache. So that is the platform isolation with virtualization which they have come up with that. Yeah, so there's the commands what we understood here. If you just observe like the Docker uh, the run with interactive approach -it, and how do we log into this the container. But by default what the user account it is using is always the containers, that means the base images whatever you are taking about it, which contains about a root user account. Like Vagrant boxes whatever we have taken, that Vagrant is the default user account. Like that all the containers are starting with the root user account. But we can launch it about our containers with about our specific users. That's we'll talk about our custom the images creation process wise. We'll see this later. But the default any image you are taking is nothing but default user account is root, and whenever you use it exec with the -it and the container id, you don't need to specify the passwords for this. So default it starts with root user account. Yeah, so that's points which we have. And now if I exit this, now the from the Ubuntu system we have exited. Now we are in Ubuntu system, sorry, CentOS system. This is about our distribution. Now here if I verify that, like docker ps command, even if I exit that also, still the container is up and running. Yeah, so you can log in a number of times. Docker exist, you can use it, and you can log in and you can work with that, and you can exit this, but your container is not going to stop it. Yeah, so that's about some commands, and that's how do we log into this, and how do we check it does the containers which are running, and how do we verify the list of all the images, docker images. And yeah, so let me just review this here. Have I missed anything or not? The docker pull command and docker run command with interactive docker ps, so no containers obviously. The docker restart, you can relaunch the containers. Now another commands, if you just observe the lifecycle point of view, you can stop the container. Docker stop with container id. How to get the container id is docker ps command, you can use it. Verify that my container has been stopped. And if you verify this once again, the ps-ea, and this is a container which was created 16 minutes ago but exited 11 seconds ago. So creation is docker run command. The creating that image to the container is the docker run command. And this is I mean, you are using the remaining all the commands, starting or stopping is nothing but your life cycle of the container, you are just using that. Yeah, so you can use it to restart also the container to start it. Either container id we can use it, or container name we can use it. Either one of that we can use it. And how to verify this is, yes, suppose one more point what we have is, yeah, so let me explain here. If I need that, suppose we have launched the Ubuntu system. Now the Ubuntu system is running is nothing that is assigned with some network interface, that means some specific IP address, or it is launched the Ubuntu is nothing that contains some environment variables or some user. So how do we know that the complete information of that the container? That means what is the IP address that is using, or what is the net mask that is using, or what is the subnet I mean the internet gateway it is using, or what are the environment variable that I have been set up that for that. So how do I know that the complete information of this the container is? So that means the images or containers can be inspected. That means you can gather the complete information of the container by using inspect command. So the images can be inspected, images we can inspect it, or the containers also we can inspect it, which returns the JSON file format. So this docker inspect is one more command which is helping. You can apply that on the images, or you can apply that on containers to know the complete detailed information of that the images or the containers. If you apply this on the images can be inspected to see the layers, what are the layers that contains it. And you can apply this inspect command on the containers. That means about runtime information of this the container. It can be used on images and containers, and -ef, which is helping about it format. If you just observe this, like the inspect command, yes, docker inspect and ubuntu xenial, that is a container, that's the image name. And docker inspect with format also you can use it, the format options. So let me show this how it is going to show here. And let me start the container, then we can understand this, or we can see some more information. Inspect to know that the information of the images or containers. If you just observe here, now it is generated the JSON file format of this container. There's so much information. Now here if you observe this ID information, so this is the ID of so this container created at what time it has been created, so what is the command that is executing, arguments which have been received, what is the current status that we have is running, and is it is in the paused status or is it sorry, is it in the restarting state, or is it killed by using out of memory exception or not. That means if it is exited with other than zero code, non-zero code, status code, then if you verify this inspect on that the container, if it is because of any the memory issues, because of that it has been killed, then you can find it. So is it killed because of this any memory issues or not, and is it dead, and what is the PID, what is the exit code statuses, and errors if it is any exited, had started at what time it has been finished that, and which image it is using. So yes, this is the image so which is using by this container. And if you just observe that, like you are launching the Ubuntu system is nothing but the Ubuntu related the host names and the hosts, and some kind of that the information it is accessing from the host OS. But from I mean where on on this host machine where it is managing this all these files which belong to this container is, you can find it the complete location of this container on the host OS. So that means like all the resolve configuration file, that means DNS configuration information of the file it is managing in this location where it is available is container internally it is using, but actually the physical location of this file is where lib docker. That means in our docker home directory in the containers folder, this is the container ID and this is the file. That means if you log into this container and if you observe that etcresolve.conf, which is having the DNS information, that file actually physically located from this on the host name path. Yeah, so these are the host name files and host file information, and the where lib some like log files information, and the container name and how many times it has been restarted, restart counts, and which type of driver it is using, overlay. Yes, so this the overlay kind of that the driving mechanism, and you can see the some most of the information nothing. And yeah, so it is using some driver mechanism. These are volumes concepts, I will explain all these later. So there's root volume which is created by mapping to about our host OS. And yeah, so there's the environment variable, you can find it. So in this container there are all the environment variables that have been set up that to the path variable. So user local has been, user local bin, user has been, and if you like to add it environment variables, how do you add it? We'll see this. I mean we have this explicitly specified that environment variables all this, but we are just understanding about it within the container, what does it contain and which command it is executed and what is the image. So no volumes are defined, working directory nothing specified. And finally you can see the some networking settings also. So which type of network it is using is bridge network by default, but what are the types of the networks are available and which one is recommended, I'll come back in the networking concepts. And if you just observe here, yeah, so this is the gateway which is using 172.17.0.1, and what is the IP address of this container which is having is 172.17.0.2. Yeah, so if you just observe this, so what is the like subnet mask which is using is 172.17.0. Whenever you install this the docker So Docker on the host OS, it is going to create one network interface, and what is the network interface subnet mask which is using is 172.17.0. And first is gateway which is helping. So for now, in this container also we can install that's all the packages. That means m install, m update, if you run it, you can, I mean, it is able to connect to that internet. But how it is able to connect to that internet? By default, automatically, the gateways, it is helping that. So this is the gateway by default which is creating. And for this system, what is the IP address which is created is, so this is the IP address. So in the networks, I will talk at this more on these concepts, like the gateway, how you can configure this about our custom gateways, and we can assign this about our custom IP addresses, like the private IP address, how we are configuring the vagrant boxes. We can configure for about our containers the custom IP addresses. But how do you do that? We'll come back. Yeah. So, but yeah. So this is complete network information, and if you just observe that, suppose if I would like to know about that IP address, how do I know that IP address? So this is the parent, this is a JSON file format. So the JSON file format, if you just observe that, so it is started here. So if I just give that ID, and I can get that ID of the container. And if I would like to know the statuses, how I can get the statuses? The parent object dot state, the current state. In that state, what is the property that contain the status is? Status. So state is the parent object. In this state, we have those attributes. What are those attributes? Status is attribute, running is attribute, paused or not, restarting or not, dead is or not. What is the pre-ID? So if I would like to use it, the format of the JSON, how the format is defined is state, and within the state with a variable name. Okay, suppose I would like to get that IP address of this container. I don't want to see this complete all that information. We have so much information, not required all this. I would like to get it about, or I would like to access this property. That means which property? IP address property. But this IP address is belong to that this parent object. How I can use it? This properties bridge dot IP address. But bridges belong to that networks. That means how I can access this bridge is networks dot bridge dot IP address. But this networks, is it a parent object or is it a hand child object? Yes, again it is a hand child object. The networks is a child object. But which one is the parent object to this networks? That is network settings. So if I would like to get that IP address, one option what we have is network settings dot IP address. I can use it. Or another approach what we have is network settings dot networks dot bridge dot IP address. Then it is going to print this value. So to get the specific property value, so how do we use it is, suppose like, I mean, the above command, if I use it a grep also we can use it, right? So if we just try to IP address, yes, from this entire whatever the output which is generating, from this entire output, wherever that IP the string is available, that is printing that. So now we have the IP address. What is the IP address is 172.17.0.2. But instead of using this grep command, if I would like to get it about this direct JSON file format. So how do we use the JSON file format? So instead of the grep, what we can use it is -f, and here you need to use it double curly braces, sorry, and parent object is dot parent object. Now, so which property here? But you need to identify this one by one properly, otherwise the value is not going to print it. So network settings, in this network settings, what is the property we're expecting is, okay, instead of using this option, like let me define this tag this. Yeah, so if you use it this format, So unexpected unclosed action. So the so .net. Oh, okay. So here the format is. So instead of using the grep, you can use it, but if you'd like to know this particular property, so just I'm trying to use it that, yes. So now if you just observe this, so from this parent object, then the network settings, and then .ip address. So now we got it this exact IP address, only that property which is belong to in this JSON file format. Yeah, so inspect with the -f and with a particular object pattern which you can use it to get the particular property value. Or if you don't want to use it, just directly use it docker inspect and then the container name or container ID with the grep options also we can use it. So which one do you comfortable? So that's you can use it to get this the complete information of this any particular information. Yeah, so there's a inspect command which is helping about it to gather the runtime information of the container. Suppose if you needed images also you can apply that. But the images you don't find it this much information because this is a static component. Now here if you observe that, so you can see this one of the important section is the layers. So these are all the 4 layers that is having in this image. So from this root file system, so layers, what are the layers we have? The 4 layers they have defined in this Ubuntu image. And it is using about that root directory. Yes, root directory, which directory it is looking about it? That means within the container we got that some amount of storage is nothing but the storage it is mapped to this about our docker home directory. So from this network option it is mapped that about our the volume. This one volumes concepts I will explain about it this. And what is the OS, Linux, architecture, AMD64, and the volumes it is not defined, and which command it is executing bin bash, and these are all the environment variables which have been set up within this image. Now we are observing within the image, but it is not having any IP addresses. IP addresses are runtime behavior, but it is just having about the image information, which image, and the container is which container it is using. This is the container which is referring this image. And container configuration, this is a completely container configuration, and the docker version, the config, and then the layers. Yeah, so there's a this is a static file, the static file information you can find it here. Yeah, so as simple as it is, inspect command is helping about it to get this the information about the images or containers. And in this in this images or the containers you can use it -f format, or you can use the grep command to get it about this the particular values of the containers or the images information. Like this is the format which we have. Yeah, the inspect grep command also we can use it, the docker ps. Yeah, running containers. And attach is one more command which is available. I'll talk at this tomorrow. Yeah, so this is about verifying and accessing any information of the container. How do we do that? That is from the container point of view. That is inspect command. Yeah, if we just conclude about it today, what are the commands we understood is how do we set up this the Docker installation? So with the repository and then Docker engine installation and starting the services and enabling the services and verifying the Docker info command. Now, if you run the Docker info, now how many containers we have? This is 2 containers. One is in running and one is in stopped. And how many images we got it? 2 images. One is hello world and the second one is Ubuntu. Yeah, so that is Docker info, Docker versions to know about the complete the host. The Docker host information on that images containers and which OS it is used, what is the memory, what is the network driver it is using. So all that information we can have it from the Docker info. That is the first section, installation and knowing that. Then commands point of view, The image, how do you pull it? Docker pull. How do you run? As a container, Docker run, and with interactive, the -it. That means the Docker run command without interactive, with interactive. And then how do we see the list of all the images, Docker images? And how do we see this list of all the containers which are up and running, Docker PS? And how do we see the list of all the containers which are stopped or running? That is -a, Docker PS -a. And how do we log into the container which is up and running? That is Docker exec with interactive, and the container ID or name, and then which shell you are going to use it, that the bin bash. That is Docker exec to log into the containers. And then yes, how do we start it, stop the containers? Docker start, container name or ID, Docker stop, container name or ID, or we can restart it. That is Docker restart, container name or ID. And how do we get this, the complete IP addresses? Or you can log into the system. Suppose if I use the Docker exec, but if config is not available, I hope so. Yeah, so the package is not available, and we can use it, the hostname -i. Yes, this is a IP address which we got it. Now the same IP address we can get it using inspect option also. Inspect, which is going to give the more information about that path informations, or like the volumes which have been set up, those network drivers which are configured, and so the complete the volumes which are mounted to the server or host OS. By default it is taking about var lib docker. In that location, any file which is mapping to the host machine is another, in that location that is available. But we'll come back to this about how do we specify about our custom the volumes. So that's, we'll talk it later. And custom networks and custom IP addresses, that is a networks point of view. Yeah, so that's points. And what else we understood? Yes, exec, inspect, and all these commands. Yeah, so that's for today on this Docker point of view. And tomorrow we go for this understanding some more commands, like how do we check the list of all the process, or how to get the events, logs. So there are some commands are available which we'll try to understand it. Then we start about it, the three options, like in the background whatever we discussed, the port forwarding concepts, synchronized folders concepts, and volumes. So we'll try to understand it under networks. There are the four concepts we are going to talk it on these Docker containers. How do you configure it? All this stuff. Yeah. So that's points for today. Any queries, questions?